Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Thanks for taking the time out to join us today from wherever in the world you might be listening. We really appreciate it. This podcast is going to talk about a topic I've promised to go into in more depth on previous podcasts, and I've recently been asked about it several times. The question is, why are two motors better than one in an electric vehicle powertrain? So as we know, most internal combustion engine vehicles have one engine, but increasingly we're seeing EVs come onto the market that use multi-motor systems to both maximize efficiency and performance. So there's some obvious packaging benefits to having multi-motors in the drivetrain. You get rid of all of the prop shaft from the front to the rear. You can package two smaller motors rather than one big motor. So there's some clear packaging benefits. I would come out with that sort of clear sort of roller skate structure that most EVs seem to be heading towards these days. But there's also some other very significant benefits that you get from going to a multi-motor system, and that's what I'm going to go into in more depth today. If we look at the Volkswagen ID.R that smashed the Pikes Peak record and then went on to break the all-time record at Goodwood, and then also the highly acclaimed Neo EP9, the road car that took the record at Goodwood as well. Everyone's seen the amazing Rimac, but also cars like the Jaguar I-Pace, the Tesla performance models. All of these cars have got something in common. They use more than one motor to drive the vehicle. There's several reasons for doing this, and although it might seem to be quite unusual when we're used to seeing cars with one engine, and we know as well that going to all-wheel drive in a combustion engine vehicle typically helps in terms of traction, especially in poor driving conditions, but it always has a penalty in terms of efficiency. And, you know, electric vehicles are really all about efficiency, so it does seem quite odd on the face of it that electric vehicles should be tending towards being all-wheel drive. And you know, there's clearly some specific reasons for that. So first of all, it's important to think about vehicle dynamics and also what the function of the electric motor is. So firstly, the electric motor, we're going to use that to propel the vehicle. So when we're doing that, we're turning electricity into torque in the motor, and that turns the wheel and it moves the vehicle. But we use it in another really important way. We use it to generate electricity, and when we're doing that, we slow the car down, i.e. we turn the car's motion into electricity that we can store in the batteries and use later. That's really important for the cycle efficiency of an electric vehicle, and this is called regenerative braking. And as the name implies, it creates a braking effect. So in theory, as much deceleration can be created in an electric vehicle as acceleration using the electric motor. So next, the dynamics part. Well, when a vehicle accelerates, there's a weight transfer from the front of the vehicle to the rear of the vehicle. You will have experienced this when in the car, you press hard on the accelerator and the front of the car will lift a little and we're pushed gently back into our seats, sometimes harder if it's a really powerful car. And then also we know when we're braking, there's a weight transfer to the front of the car. So the nose of the vehicle dips a little bit, the rear lifts, and we're pushed forwards on our seats into the seatbelt. Or if you brake really hard, your nose is pressed against the windscreen. Under hard acceleration, it's best to have the rear wheels driving, as the weight transfer to the rear of the vehicle causes the front wheels to have less grip than the rear wheels. But under braking, the reverse is true. The front wheels do all the work. Just look at the size of the brakes on the front of your car compared to the rear of your car. Because the rear of the car goes light under braking, the grip in the rear tyres is significantly reduced. If we did too much braking at the rear of the vehicle, it would cause the wheels to lock up and the vehicle would become unstable. In a rear-wheel drive car, This limits the amount of regen braking you can do, because if you were doing too much regen braking at the rear of the vehicle, it would unsettle the handling of the car, especially if you're going around a corner, you were braking a little bit, the weight transfer is to the front. It would really have a negative impact on the handling of the car. And then that limits the amount of energy you can recover and put back into the battery. So the ideal scenario is to have all-wheel drive, where you have motors at the front and also connected to the rear. So the motors at the rear can work harder under acceleration, and the motors at the front can do more work under regen braking without having a negative impact on vehicle stability. So cars like the Neo EP9 and the Rimac have 4 motors, 1 on each wheel. In this case, we can delete the differential that's normally used to split power between the wheels. So that saves a bit of weight. And it also means that the amount of torque delivered to each wheel can be very precisely controlled. This is called torque vectoring. Now, it is possible to do torque vectoring mechanically with quite a complex system of clutches and brake actuation, but it's really simple to do this in a 4-motor setup where the torque can be very, very precisely controlled instantaneously. Controlling the torque in this way really transforms the handling of the vehicle. It means that when a wheel goes light under cornering, or when you lose grip at the front because you're doing heavy acceleration, deceleration, you can really precisely control where the torque goes. And it's it actually has quite a strange sensation when you're driving. You get basically the performance of having a lock differential, but without the negative kind of driving characteristics of a lock differential. So the problem with a normal differential is that when one wheel goes light, the diff will put all of the torque to that wheel. So you basically end up with wheel slip on one wheel. And most people will have experienced that. If you're pulling away hard in a car, you tend to get one wheel slipping rather than both wheels. And that's because you've got less grip at that wheel. And the way a mechanical differential works actually puts all of the torque to the wrong wheel, basically puts the torque to the wheel you don't have grip in. So in a high-performance vehicle or a racing car, you'd have what's called a lock differential or a limited slip differential, and that changes that. But these can have quite a negative impact on the handling of the vehicle because you get a kind of shoving effect in terms of how they put torque down. So being able to precisely control the torque with an electric motor wheel to wheel gives you some really quite significant handling benefits. And these benefits don't just stop in terms of race cars and really high performance. They can be big help in a commercial vehicle or in off-highway machinery, because you can really reduce the tyre wear that you get from wheel slip or tyre slip caused by conventional differential during tight manoeuvring. So when you're moving a truck around and you're doing tight turns, you get weight transfer from one side of the driven axle to the other. And what can happen is you'll get slip on the lighter loaded wheel. So having a multi-motor system in a commercial vehicle can be quite a big advantage as well, but more from a reducing tyre wear point of view, and that's a big cost to commercial vehicle operators. So there's more advantages though, actually, in having a multi-motor system, and it's a further advantage in terms of efficiency. So we know now, obviously, we've got the ability to do more regen braking, but as a further efficiency advantage of splitting the power between multiple motors, in an electric drivetrain, the main source of losses are what's sometimes known as copper losses, although this can happen in any conductor material, or sometimes it might be called a winding loss in a motor, but it's basically the loss generated by passing an electric current through a conductor due to Joule heating. That's Joule, Joule, heating. And it's a function of the square of the current times the resistance of the conductor. So in an electrical system, power is simply volts times current. So, for example, a 200 kilowatt motor on a 350 volt DC system will draw 571 amps of current. Okay, so that's P, 200 equals V, 350 times I, 570. The losses in that system will then be 571 squared times the resistance of the conductors, and at a system level this will include the windings in the motor, all the cabling that interconnects, and of course the switching resistances inside the inverter. But if we replace the single 200 kilowatt motor with two 100 kilowatt motors, we immediately halve the current in each motor and the inverter and the whole system to 285 amps. And because the losses are proportional to the square of the current, this simple move halves the losses in the system, okay? And that's because 570 squared times the resistance compared to 285 squared times the resistance times 2, okay? So you halve the losses. Dividing the power between 4 motors means reducing the losses by 75%. Okay, I know a few people are going to be reaching for their calculators right now. The maths does work out. If you're driving a car, please do not use a calculator. Wait till you're at your desk later. So having multiple smaller motors also means there's that we can achieve improved cycle efficiency over a typical driving cycle. We can optimize the multi-small motors much better than we can a single large motor. So imagine a driving cycle, the motors aren't always at high torque. There are sometimes low torque, medium torque, all being operated at different conditions throughout the torque speed range of the machine. Having one big motor, it's harder to optimize that across a driving cycle than it is with multiple small motors. So multiple small motors can give us cycle efficiency there as well. So we have significantly reduced I-squared losses in the system, and we can optimize the motors better for driving cycles. Okay, so there you have it. That is it. That is the reasons why more motors are better in an EV. It's always a case that more is better, or it's not always a case that more is better, but in an EV, in the case of traction motors, it is a case that more is better. The exceptions to that are if it's a very, very low-cost, cheap, low-power EV, then the compromise solution is a front-wheel drive with a low-power motor. You're not going to have any issues with slip or with traction. But as soon as you're approaching the grip limits, the traction limits, much better having the power split between the front and the rear of the vehicle. We can recover more energy under braking without having a negative impact on stability. We can do clever things like torque vectoring to take handling to a completely another level. And we significantly reduce the I-squared-R losses in the system. Okay, that's all. So thank you very much for taking the time out to listen to this today. I really hope you found it useful. Please feel free to ask us any questions on this or any other EV powertrain topics that you might have. Don't forget to subscribe to the channel on whatever platform you might be listening to us on. We're now on loads more platforms. We got that sorted. Thanks to people asking for us to be on Spotify and put our podcast on YouTube as well. So we're now on much more platforms. So don't forget to subscribe to us so you get all the updates. There's going to be about one a week, sometimes a bit more. Also, please leave us a rating or hit a like, depending on which platform you're listening on. That really helps. That helps more people then to see this so that we can connect with them as well. So thanks very much. Look forward to speaking to you again soon.